The difference is literally night and day. That's what you'd expect to hear, but most people who watched the Artemis II launch had the same thought. We already did this, and in a way they're right. A crew, a rocket, the moon. It looks familiar. The countdown, the ignition, the crowd watching from the coast. You could be forgiven for thinking that 2026 is just 1969 with better graphics. But it raises a question worth actually answering. Are these two missions actually comparable? Or is Artemis something fundamentally different from what Apollo was? Built from different technology, designed for a different purpose, carrying a completely different set of capabilities? The answer turns out to be more interesting than most people realize. Some things changed completely. Some things barely changed at all. And at least one difference, the photographs, has confused people in a way that nobody expected. Start with the most visible difference, the rocket. The Saturn V stood 363 feet tall and generated 7.5 million pounds of thrust at liftoff. For over 50 years, it remained the most powerful rocket ever successfully flown. The Space Launch System that carried Artemis II stands 322 feet tall and generates 8.8 million pounds of thrust, about 17% more than the Saturn V. So the SLS is shorter but more powerful. That sounds like progress. The cost complicates that story. A Saturn V launch cost approximately $1.4 billion in today's money. A single SLS launch costs approximately $2.6 billion, with some estimates from the Government Accountability Office placing it above $4 billion when all costs are included. Both rockets are expendable. They fly once and are not recovered. SpaceX lands its Falcon 9 booster on a drone ship after every flight. The SLS is discarded in the ocean each time. That is the same approach NASA used in 1969. The RS-25 engines on the SLS core stage are the same engine design that powered the space shuttle for 30 years. Rebuilt, recertified, but the same fundamental design. What looks like a new rocket carries at its core hardware from a program that ended in 2011. The Apollo Command Module carried 3 astronauts in approximately 210 cubic feet of habitable space. That is roughly the interior of a large closet. 3 grown men sealed in there for up to 12 days. The Orion spacecraft that carried the Artemis II crew offers approximately 330 cubic feet, about 30% more room, spread across 4 people instead of 3. It has a dedicated hygiene area with a proper toilet, privacy curtains, a flywheel exercise device, a food warming system, and a digital communication setup that allows video calls with the crew's families. The Apollo Command Module had no toilet. The crew used adhesive plastic bags. Nearly every Apollo astronaut who has spoken honestly about the experience describes this as one of the worst parts of space travel. Artemis II had a toilet. It broke during the first day in orbit. The suction fan on the liquid waste hose stopped working, forcing the crew to resort to bags for urination. The gap between 1969 and 2026 for sanitation purposes was narrower than most people would like. Apollo was powered by fuel cells. Hydrogen and oxygen combined to produce electricity and, as a byproduct, drinking water. Elegant but finite. Every watt the crew used came from a supply that was depleting. Orion draws power from 4 solar array wings, renewable as long as the sun is shining. The spacecraft's fully deployed wingspan is approximately 63 feet. This changes the psychology of the mission. Apollo crews were always counting their consumables. Orion's electrical supply regenerates itself. The surface module bolted to the back of Orion was not built in the United States. It was manufactured by Airbus in Germany under contract from the European Space Agency. It provides propulsion, thermal control, and life support. Apollo was American from the rivets up. Artemis is international by design. The Apollo program sent 24 people beyond low Earth orbit. Every single one of them was an American man. This was not an accident. The pipeline that produced military test pilots in the 1960s was exclusively male and, in practice, exclusively white. The program reflected the society that built it. The Artemis II crew of 4 included Victor Glover, the first person of color to travel beyond low Earth orbit, Christina Koch, the first woman. Jeremy Hansen, the first non-American, a Canadian Space Agency astronaut whose presence reflects a treaty signed in 2020 formalizing Canadian participation in the program. Reed Wiseman, the mission commander, became the oldest person to travel toward the moon. All 4 records on one flight. The Apollo crews were highly accomplished, test pilots and engineers selected through an intensely competitive process. The Artemis II crew are equally accomplished. The difference is not in the quality of the astronauts, it is in who was allowed to be considered. Before we get to the computers and the cost, there is something that happened during the Artemis II mission that nobody predicted. The photographs triggered an argument on the internet. NASA released the first full Earth image taken by the Artemis II crew on April 3, 2026. Commander Reed Wiseman shot it through the Orion window with a Nikon D5, a professional digital camera, at a distance of approximately 100,000 miles from Earth. The image was titled Hello World. Shortly after, NASA posted it side by side with the Blue Marble, the famous whole Earth photograph taken by the Apollo 17 crew in December of 1972. Hundreds of thousands of people immediately noticed the same thing. The 2026 photo looked less vivid than the one from 1972. The colors in the Apollo image were richer, more saturated. Earth looked almost luminous. The Artemis image was accurate and extraordinarily detailed. You can see both the aurora borealis at the North Pole and the aurora australis at the South Pole simultaneously, which has never been captured in a single photograph from space. But it did not have the same visual punch. In an era of smartphone cameras and AI image processing, the 54-year-old film photograph looked more alive than the modern digital one. The explanation is simple, but easy to miss entirely. The Blue Marble was taken in direct sunlight. Apollo 17 was heading toward the moon on a trajectory that placed the sun behind the spacecraft, fully illuminating the planet below. That is essentially perfect photographic conditions. The Earth in that image is lit the way a subject is lit when a photographer places it in front of a window on a bright day. Hello World was taken at night. Wiseman took it just after the translunar injection burn, on a trajectory where the Earth was between the spacecraft and the sun. The planet in the photograph is illuminated entirely by moonlight, light from the moon reflecting back onto the surface of the Earth. The camera settings tell the whole story. f4, a quarter-second exposure, and ISO 51200. That is an extreme low-light photography setup, the kind used to shoot stars or candlelit rooms. Wiseman was photographing Earth in the dark. The Apollo crew took the Blue Marble with a Hasselblad 500 EL camera loaded with 70mm Kodak Ektachrome film at f11 and 1/250th of a second in brilliant sunlight. The Artemis crew took Hello World with a 10-year-old DSLR in near total darkness, shooting with moonlight alone. That is not a technology gap, that is a lighting difference, and it was invisible to almost everyone who compared the two images. There is another difference between the two photographs, and it is harder to explain with camera settings. The Apollo 8 astronauts were explicitly told not to waste film on photographs of Earth. Mission Commander Frank Borman's instructions were direct. I don't want to see you looking out the window. Earth photography was listed in the mission plan as a target of opportunity, the lowest possible priority. The famous Earthrise photograph from 1968 happened because Bill Anders noticed something out of the corner of his eye as the crew was photographing the lunar surface in black and white, grabbed the nearest camera, swapped to a color film magazine, and took what became one of the most reproduced images in history. It was an accident. The Artemis II crew spent weeks training with geologists and scientists specifically to photograph and describe the moon. They had an official science observation plan for the flyby. 5 of Orion's 6 windows had live streaming cameras. The mission carried 32 cameras and camera-capable devices in total. The crew took approximately 10,000 photographs during the 6-hour flyby period alone, more than twice the total number taken across the entire Apollo 17 mission. Apollo treated photography as a distraction. Artemis II treated it as a primary mission objective. The Apollo guidance computer had approximately 72 kilobytes of memory and could execute around 40,000 instructions per second. That is less computing power than a modern pocket calculator. The entire Apollo 11 mission, trajectory calculations, guidance, navigation, life support monitoring, was managed by a device that a mid-range smartphone would embarrass in every measurable way. Orion runs 4 independent computers in parallel. Each one is approximately 25 times faster than the computers on the International Space Station and 400 times faster than the Space Shuttle's onboard computers. Taken together, Orion's computing system is roughly 20,000 times faster than Apollo's single-flight computer and about 75% lighter. The Apollo cockpit was analog: physical switches, dials, mechanical gauges. Astronauts read instruments manually and calculated corrections with support from Houston, doing most of the heavy mathematics on the ground. Mission control was not optional. It was structurally essential to how the spacecraft functioned. Orion has a digital glass cockpit, screens, software interfaces, real-time trajectory visualization. It can, in principle, fly itself. It demonstrated this on the Artemis 1 uncrewed mission in 2022, completing a full lunar orbit and returning entirely autonomously. During Artemis 2, Victor Glover flew the spacecraft manually during deep space maneuver demonstrations. Not because Orion needed a human pilot, but to test whether a human pilot could guide the vehicle through precision operations that future missions will require. Apollo communicated with Earth using radio waves. This worked. The audio was scratchy, the bandwidth was narrow, and transmitting a single photograph took several minutes. The total data returned from an entire Apollo lunar mission was measured in megabytes. Orion's primary high-bandwidth system uses infrared lasers. The Artemis 2 optical communication system, known as O2O, transmits data between the spacecraft and 2 ground stations in New Mexico and California at speeds radio cannot approach. By the 4th day of the mission, O2O had already downlinked over 100 gigabytes of data, including high-resolution photographs that the crew had taken through the windows. Photographs taken 100,000 miles from Earth were visible to the public within hours of being taken. The communication delay at lunar distance is about 1.3 seconds each way. This is the same for Apollo and Artemis. The physics of the speed of light has not changed in 54 years. The Apollo program cost approximately $25 billion between 1961 and 1973. Adjusted for inflation to 2026 dollars, that is roughly $290 to $300 billion, depending on the inflation index used and which related programs are included. The Artemis program, measured from its formal launch in 2017 through the projected Artemis 4 lunar landing in 2028, is expected to cost approximately $105 billion. That is less than half of Apollo's inflation-adjusted cost. This comparison requires context. Apollo was not a cost-optimized program. It was a Cold War emergency. Congress gave NASA whatever it asked for. At Apollo's peak, NASA's annual budget reached the equivalent of roughly $42 billion per year in today's money. The agency had a workforce of nearly 35,000 civil servants by 1964. Artemis has averaged about $6 billion per year and operates with approximately 14,000 civil servants, NASA's smallest workforce since before Kennedy announced the moon goal in 1961. Artemis is attempting to return humans to the moon at roughly one-third the annual spending rate of Apollo. This helps explain why it has taken longer and encountered more delays. It is not a less ambitious program. It is a program with a fundamentally smaller budget trying to accomplish a comparable goal. Whether it represents good value is a different question. A single SLS launch costs more than $2.6 billion for a rocket that is used once. SpaceX's Falcon Heavy, which can carry heavy payloads to deep space, costs approximately $150 million per launch and is partially reusable. The debate over whether NASA should continue with SLS beyond Artemis 2 is active and unresolved. The most important difference between Apollo and Artemis is one that does not appear in any technical specification. Apollo had a single specific objective: land a human on the moon before the Soviet Union and come home safely. Once that objective was achieved, on July 20th, 1969, the program's reason for existing began to dissolve. Budget cuts followed. The final Apollo mission, Apollo 17, flew in December of 1972. Then nothing for over half a century. Artemis is not designed to win a race. It is designed to establish a permanent human presence on the moon, a base near the lunar South Pole, regular missions, a platform for eventual Mars missions. Artemis 2 was not a destination. It was a systems test for everything that follows. Apollo went to the equatorial near side of the moon, flat terrain in daylight, selected for landing safety. Artemis 3, when it lands, will go to the lunar South Pole, a region of permanent shadow and extreme terrain where water ice is believed to exist in craters that have not seen sunlight in billions of years. That is not a variation on what Apollo did. It is a different mission to a different place for a different purpose. Apollo proved we could get there. Artemis is attempting to figure out how to stay. So, are these two missions really comparable? In some ways, no. The computers are 20,000 times faster. The power supply is renewable. The communications are orders of magnitude faster. The crew is diverse in ways Apollo never was. The photographs are downlinked live instead of waiting for film to be developed after splashdown. The spacecraft can fly itself. In other ways, they are more similar than expected. Both rockets are expendable. The SLS costs more per launch than the Saturn V did, adjusted for inflation. The cabin is bigger but still cramped. The mission profile, leave Earth, fly to the moon, come home, is the same arc. The biggest difference is not in the hardware. Apollo was a sprint with unlimited fuel. Artemis is a marathon with a budget. Apollo was one nation's Cold War urgency, compressed into a decade. Artemis is a multi-decade international program designed to build infrastructure that outlasts any single administration or budget cycle. Whether it succeeds will depend less on the computers and the solar panels and the laser communications than on whether the political will to fund it survives long enough to matter. Artemis 2 launched and returned safely. The heat shield held. The crew came home. The next step, landing on the moon for the first time since 1972, depends on what happens next. If you want to understand the full Artemis 2 mission in detail, what the crews saw on the far side of the moon, what the heat shield revealed, and what happened during the 40-minute communications blackout, watch Artemis 2, the complete story. Everything from launch to splashdown.